Okay, so in this video, we're going to look at example one and how we run the goodness of fit test. So if you haven't read it, make sure you pause and read example one. In the first video, I briefly talked about example one and about how to find the observed and the expected. So just as a reminder, we're talking about ice cream flavors, and the observed are the values from the sample, and those are those counts. So we put each of those counts in the right category. And then the expected is how many we expect to get based on the percentages. And they, again, always have to be counts, not percentages. So we take the percentage as a decimal and we multiply it by the sample size to get each of the expected values. Okay. And sometimes they write it as like the probability of vanilla is 0.25, the probability of chocolate is 0.25, probably strawberry is 0.20, and the rest would follow. But we take each of these probabilities and we multiply them by n to get the expected frequency. So we're going to first write the null and the alternative hypotheses. So for these problems, they're a little bit different than all the other ones we did. The null and the alternative are always in words, and the null is always the model or the distribution of, and then we give the context, ice cream flavors is consistent with the model. And that is usually the null. And then the alternative is that it's not consistent. So the distribution of ice cream flavors is not consistent or inconsistent with the model. So that's always our null and our alternative. Just make sure to include the context. And what it's saying is for the null, we always assume that the observed and expected would be the same, that they would equal. And the alternative is that they're not equal. So at least one of them is not correct. Or it could be multiple of them is not correct. Okay? And so we're going to test if there is a statistical difference between the observed and the expected. So B said find the expected counts. We already did that. And then we're going to run the test. So the test is called the goodness of fit test. And that finds the chi-squared value, which gives us the percentage change between the observed and the expected, like the sum of that. So the chi-squared, we're not going to do it by hand, but what it does is it takes the observed minus the expected, it squares it, and then it divides by the expected. And then it adds those all up to get the chi-squared value in. So it's measuring kind of that distance between the two. So we will run the GOF test. And again, if you have an older calculator, you won't have this test and you'll need to watch the other video on how to do that. But if you have the GOF test, so when you go to stat over to tests and you have to scroll down a little bit, under D, if you have this chi-squared GOF test, you can just run that. So notice it says observed is L1, expected is L2, and then you have to put DF, which stands for degrees of freedom. And so how it works is we entered our observed in L1, we enter our expected in L2, and then we have to put the degrees of freedom. And the degrees of freedom is the number of categories minus 1. So for the problem, you want to go again to stat, edit, and enter your values. I already have mine entered, so you want to pause and enter. L1 should be your observed values, and L2 should always be your expected. Then you're going to go to stat over to tests again to the GOF test, which is D, and hit enter. And the only thing you'll have to change is the degrees of freedom. So the degrees of freedom is the number of categories minus 1. The number of categories is, like in this case, how many flavors I have. So I have 1, 2, 3, 4, 5, 6. So the degrees of freedom would be 6 minus 1, which is 5. Okay, so you count again how many like columns of data that I have, and that would be the number of categories. And so we're gonna change that to 5 if it's not already. Hit calculate. Or I have 2 calculators up. Hit calculate. And you're gonna get the chi-squared, which is the test statistic, okay, and then the p-value, which again is the probability of getting the results of this sample, given that the null is true. Okay, and you have to give both the chi-squared and the p-value. So the chi-squared is the 9.679, and then the p-value is the 0.08. And then from there, everything else follows the same that we've done. So if I go back, my alpha is 0.05. So 0.08 is greater than 0.05. So we fail to reject. And then we write our conclusion. Okay, so for this conclusion, we say, since the p-value is greater than 0.05, we fail to reject the null hypothesis and conclude, because we're rejecting, we're saying there is enough evidence. And then remember, we always talk about the alternative hypothesis. So if I come back to my alternative hypothesis, we're gonna say that the distribution of ice cream flavors is inconsistent with the model. Be careful about using the question, because in this case, the question says, is the sample consistent with the model? And that's the null. And remember, when we talk about the conclusion, we always talk about the alternative, if there's evidence or not. So because we're not rejecting, we're saying there's not enough evidence, and then we're going to put what this alternative is. So we're going to say not enough evidence. The distribution of ice cream flavors is inconsistent with the model. Okay, so you should always be talking about it being inconsistent with the model when you're doing these problems, because you're looking at the alternative and not the null. So that is the chi-squared distribution. And then we'll do a few more examples to practice with this in class.